Welcome. This question says a 3i plus 2j plus 4k Newton force, that's a three-dimensional force, is applied to a particle. The particle has an initial momentum of 1i minus 6j plus 7k kilogram meters per second. So that's its momentum at time t equals 0. What is the momentum of the particle at times t equals 5? So let's visualize it. There's my particle, and let's start off with this force, and this is going to be 3i plus 2j plus 4k newtons, and it's kind of trying to accelerate it in that direction. But the particle's already got some mass and velocity, and that's represented by 1i minus 6j plus 7k, and this would be kilogram meters per second. I don't know anything that you don't know about these directions. I'm just drawing them schematically. And so what happens is we get some some changes, and then at some time later, and this is at t is equal to 6 seconds, 5 seconds, we have another momentum, p final. We want to find p final. So we say, well, we need something that links these things together. We have a F. We have a PI. We have a initial time of t equals 0 seconds, so we have a delta t. And I get thinking and I go, you know, this is basically saying that F is equal to dp by dt, the time rate of change of momentum, which equals, well, on average, it's the change in momentum over the change in time, which equals p final minus p initial over my, let's say, t final minus t initial. Let's write it like that. And so I look and I say, can I put numbers or things in this? Oh no, let's rearrange. I've got ijk, so I like to rearrange completely with ijk. So let's have a look. I want to find p final. So I'm going to say, okay, p final is equal to f. This is my change in time. Let's put it down as change in time. It's dividing initially, so it multiplies when I move it to the other side. Divided by, oh, sorry, not divided by. So I've taken that to the other side. I've got this that I want. I need to move this p initial plus p initial. So there's my system, my equation. I go I, j, k. I set up a little grid system. This is a way of just laying this thing out so I can get some decent numbers. It enables me to keep track. And the first thing I want is f times delta t. Well, I know my f, and I know my delta t is 5. So let's just multiply this by 5. So rather than 3, I would have 15. And rather than 2, I would have 10. And rather than 4, I would have 20. And that is f delta t. And then the next term I need to do is I need to talk about pi. My initial velocity, my initial momentum is there. So that's 1. And that's minus 6. And that's 7. And this is pi. And this operator there tells me to add these two guys together. So that means I have 16i plus 4j plus 27k. I'm running out of space there, so let's put that like that and say my answer is 16i plus 4j plus 27k, and this is going to be, of course, it's going to be momentum, so it's going to be kilograms meters per second. So kilograms meters per second, it's that guy there. And there we have it.